Flack math! Give me some math and I'll give you some flack. Flack math!
So usually when you see factor, what we've done in the past is we've looked for a greatest common factor and we've taken it out and things like that. So you're undoing like a math problem, right? You're undoing a multiplication problem. So for example, if I had like 21, that's just 3 times 7. That's what it means to factor something, okay? That's more like the opposite of multiplication. Instead of division, you're taking a multiplication answer apart and figuring out the different parts of that problem, okay? So that's what we're doing here. So let's do a little bit of review. Let's say we've got x minus 5, x plus 2. So how do we multiply these two together? What do we do? Yeah, FOIL. So that one is x squared. That's usually the easiest one, right? And then you got your 2x. And then you got your negative 5x. And then you got your negative 10. Right? Okay. And then what ends up happening is these two combine. So you get that answer. So you get x squared minus 3x minus 10. Okay. So let's just see if we can take this apart. Look at this answer. Look at this answer to factoring. Well, we know where this x squared came from. It was just multiplying the first times the first, right? And the negative 10, that's always just multiplying the last times the last. So this is the F answer. Hi.
I'm sorry, Miss Myers can't get her TV to work.
Oh, okay.
You might know you don't even you can see something in like 5 seconds.
Sure, yeah.
You know, show you faster.
Yeah.
Does everybody? Yeah, you guys are all angels. Oh my goodness, who's this? Is this an angel too? Yes, that's an angel. You guys all did okay for a few minutes?
Large and huge adventure of
That's so smart. So maybe we can do that for next hour. But for this hour, we'll just review real quick. So there's 6 people this time.
I don't know. We have some pages in our book. That's not a bad thing. Oh my god, look at the page and I was like, oh yeah. Yes, that one is so
All right. So So what we're going to do is we're going to go backwards. So we're going to take this answer and we're going to say, okay, what was multiplied by each other to get that? Just like we did here. What times what equals 21? Well, so this is a little bit more complicated because there's more to it, right? Well, this was easy. So that can only be x and x. So then you're half done, right? So then, and then you've got some different options. You've got this -10. Well, this -10, it could be 1 times -10. It could be -1 times 10. It could be 2 times -5. It could be -2 times 5. You've got like 4 different options, right? But how did you get this -3? Well, that was when you multiplied this 2 times the x and this -5 times the x, and then you added them together. So really, forget about the x. 2 and 5 added together is -3, right? So what factors of -10 will add to -3? So there's a magic question, okay? What 2 numbers multiply to get this last term, but then will add to get the middle term? So let's try another one. So let's try one from scratch here. So let's try x squared plus 7x plus 12. Okay, so the first thing you do is start with your parentheses and your x's, because the only thing that can equal x squared is x times x. So you're half done, right? Now you just have to figure out what numbers these will be, okay? So if I kind of reverse FOIL, so this is x squared, we knew that, and then this is going to be something x and another something x, and those something x's will add to get 7x, but those somethings multiplied will give you 12. So what are some factors of 12?
Yeah.
So
Yay. There.
don't be shy.
You did 3 times 4.
Yeah, so if you try 3 and 4, let's see if that works. So I'm going to say positive, positive. So when I FOIL it out, I already knew this, but I'm going to say x squared. And then I get 4x, 3x, 12, right? And that gives you 7x. So x squared plus 7x plus 12. Okay. Now, you can see why this is exciting to me, because it's like a riddle. What 2 numbers multiply to get 12, but add to get 7? Okay, well, that's 3 and 4. 2 times 6 equals 12, but 2, when you FOIL it out, 2x and 6x will give you 8x, not 7x. Okay, so this is exciting. All right, let's try another one. See if you can figure out this riddle.
Altogether 6. Fun times. Why are you at school?
Okay, can you figure out how to factor that?
So let's think through. I want you to take a minute, think about what we've learned about Westward expansion. Think about any questions you might have, as well as just some of the themes that we talked about. We're going to talk those through.
What's nice is you can just be half done already without even thinking about it. So how do you make it so you're half done already? What should I do first? Okay, what do you start with? Yeah, so you can put the x's there in the parentheses. Okay. I have to tell you this just because I've told all my classes this, and it's going to disturb you, but it's easy. It makes it easy to remember. Okay. Always start with the cheeks and tats. Okay. Start with the butt cheeks and the tattoos on the cheeks. Okay. So I know it's disturbing, but it helps you remember.
Okay.
Start with the cheeks and tats. All right. And you're half done.
What
Okay. So
question?
what two numbers multiply to get 15 and add to get 8?
Is
You got it?
long? It's a normal size text.
What two numbers multiply to get 15? Brianna? 5 and 3. Okay, now does it matter if you say 5 and 3 or 3 and 5? No, because when you FOIL it out, you get x squared and you either get 5 or 3x, and you get 5 or 3x here, it doesn't matter. Now, pretty soon it will matter, but for now, especially when everything's positive, everything stays positive, okay? All right, let's try to complicate it. So this was a little weird. If you look at this, it's still what two numbers multiply to get not 10, but negative 10.
18.
But then what adds to get negative 3? Well, look, negative 5 times positive 2 is negative 10, but when you combine negative 5 and positive 2 together, you get negative 3x, okay? Now, here's what your brain's going to do. Your brain's just not going to take this lying down.
So,
Your brain's not going to say, okay, I get it. Your brain has to FOIL it out. So your brain has to do this. In order to learn this concept, you have to check it. Not because it's a math problem and you're supposed to check your math problems, but because your brain needs this to fulfill
gold rush.
the learning process. So you have to FOIL it out. So your brain learns it forwards and backwards, okay? Because remember we talked about how sometimes our brains don't know when you're doing something forward or backwards, okay? Especially if you're dyslexic or dysgraphic, sometimes your brain has trouble
What industry?
deciding whether you're doing it forward or backwards, okay? But that's how we learn too. If we learn it forward and backwards, then that's really good for our brains, okay? So let's try some other examples.
Wait, Mr. Brown,
Yes.
what was our final
What
correct
other?
So this is your answer.
answer? Okay.
So you want to know what times what equals that. So this is just us checking it out, okay? Okay, so when you do your homework, make sure you check your answer. All right, let's try something here.
Sectionalism.
Let's
What
try
are
this.
3 regions or sections?
Okay, so what do you start with?
X's.
Cheeks and tats? You don't have to say that if you don't want to. If it makes you uncomfortable, then don't say.
That's the gold rush. How do we get the land? That's California.
Now would you do the 18?
Yep, so what about the 18?
Like what times what equals
Yes.
18?
Okay, what are some options here?
You could do negative 9 times 2.
Okay, what else?
2 times negative, or
Yeah,
negative 2 times 9.
yep, good.
Or you can do negative 1 times 18, and then negative 18 times 1.
Okay, good. So we could start trying these. We could start plugging them in. Let's do negative 9 and 2. FOIL it out. You knew you were going to get x squared. So you don't really need to even do the f one, right? So you don't really need to do the first times the first, because you already know that's going to be, x squared. And you already know this one, because that's why it's in this list. That's what equals negative 18. So you already know these things. What you're trying to figure out is if these two middle terms are going to combine to negative 3. Well, you get 2x,
Mexican
you get
American.
negative 9x. Will those combine to negative 3?
That leads to the Mexican.
Not quite, but your brain needs to do it. Your brain needs to work it out and see if it works. What other options are there? So if 2 and negative 9 didn't work, do you think negative 2 and positive 9 will work? No, that'll give you a positive 7x, right? Instead of a negative 7x. What else? What do you want to try? Let's try negative 6 and 3.
Goodness. Yeah. Say that for a while.
Let's try negative 6 and positive 3.
Really say X or anything.
And you get x squared, we already knew that, and then a 3x and negative 6x. So that combines to a negative 3x. Yeah, that works. So there's our secret numbers, negative 6 and positive 3. That's exciting. Okay, so we've got some different scenarios, right? We've got this scenario where if everything's positive, that's kind of nice because you're literally answering the question, what two numbers multiply to get 15, but add to get 8, okay? Because when you have like signs, you add, right? Well, you're still adding to get negative 3, but you're adding unlike signs. So you could ask yourself, what two numbers multiply to get 18? And since 18 is negative, they have to subtract to get 3. Well, that's kind of confusing. So just keep it like this. This is your magic question. And you can write this down. What two numbers multiply to get the last term, or the constant, but add to get middle term's coefficient. Okay, so this is the x term. Not the x squared, but the x term. Okay, so what two numbers multiply to get the last number, last term, but add to get middle term's coefficient? So the middle term's coefficient is negative 3. The last term is negative 18. So negative 6 times positive 3 equal negative 18, but negative 6 plus positive 3 equals negative 3. So that works. All right. So when you have a negative last number, you're going to have unlike signs. And basically, this guy, the sign of this one, tells you which number is going to be bigger, right? Because when you add it together, you have to end up with more negatives. You have to end up with 3 more negatives, right? So what two numbers multiply to get 18 but differ by 3? So 6 and 3 differ by 3, but the 6 has to be negative because you have to end up with more negatives, okay? So you don't really have to analyze it too much. Sometimes it's faster to just try some numbers and see if it works, okay? So let's try another example. Let's try this one. X squared minus 8x plus 16. Anybody got it? This is a little weird. This is different. This is a different scenario. We don't have a negative last term, but we have a negative middle term and a positive last term. That's a little weird. Do you know what it is, Audrey? Yeah, that's right. So we know that 4 times 4 equals positive 16, but also a negative 4 times a negative 4 also equals a positive 16. Now we didn't really consider this negative times a negative over here, because we didn't have to add to get a negative number. So two numbers, two positives, multiply to get a positive and add to get a positive. But two negatives still multiply to get a positive, but they add to get a negative. So start with the parentheses. Okay. So there's different options, but this is positive, so they have to be the same sign. So negative 4, because when you multiply that out, x squared minus 4x plus 16. So x squared minus 8x plus 16. Okay, good job. So there's really just three different scenarios, okay? You got all positive, stays positive. That's great. That's not the case with all negatives. All negatives does not mean both are negative, okay? It means that you're going to have unlike signs because that's how you get a negative product. But to get a negative sum, you just have to make sure that the negative is bigger than the positive. Okay, so that's the different scenario. And then the third scenario is when you have a positive last term and a negative middle term. That means your factors are both going to be negative. Okay, so again, you don't have to know all those secret shortcut kind of things. You can just try it and your brain will develop its own shortcuts. Okay, all right, let's try something else. All right, let's see if you can factor this. So this is officially example 1. X squared minus 14x minus 15. Let's see if you can factor that. Got it, Oaken?
Is it negative 15 and 1?
That's it. So what do I write?
I put x minus 15 in that parenthesis, and then x times 1.
Or plus 1. Yep. Yep. Good job. Awesome. So FOIL it out. X squared, 1x, negative 15x, and negative 15. Well, these combine to negative 14x. Check. It works. Okay. Good. All right. There's a few more. We'll do a couple more just because it's fun. And then you'll get plenty in your homework. So make sure you get lots of practice. So I really believe this, okay? If you don't find this at some level of enjoyable, then you don't understand the concept like you should. So if you really understood how to do these, which most of you are getting there, okay? So, but when you fully understand these problems, this will be maybe not fun like Elitch's fun, whatever, but it'll be very satisfying. Like you just solved a crime. Like every time you did it, they're like, wow, that's satisfying. It satisfies my soul to do this problem, okay? So if you're not having fun, then talk to me because something's not clicking. So I know that's a bold statement, but if you understood these, then there's going to be some kind of level of twisted, maybe not, I don't know, it's fun, okay? All right, let's try 2 more examples, 3 more examples, 2 more examples, 3 more examples. Example 2. I'll just write them all up here, see if you can factor them. X squared plus 3x minus 10. Example 3. Negative 5x plus x squared plus 6. And example 4. X squared plus 5 plus 6x. Trying to be tricky. So see if you can factor those 3 trinomials. How you doing? Get the first one?
I think I got the first one. I'm working on the third stances, I thought.
Yeah.
Is that good? Is that bad?
Is that x minus 7?
Yeah.
Okay, so that's not quite right, but
Well, couldn't you, for example, 3, couldn't you switch them around?
yeah, so you definitely need to write them in order first. So that was, Saxon tried to trick you by not writing them in order. So. No zeros. Are you distracted at all?
No, it's fine. I'm just
Right,
trying to
yeah.
figure it out.
I know it's hard to think sometimes. What's up with your knee, dude?
Stupidity.
Oh. Did you twist it or something?
No, in dance I wasn't bending my knees when I would land from giant leaps,
Oh
so
my goodness.
it's no bueno when you do that.
Yeah. Did you tear anything?
I think it's just gonna bother me for a couple of days and then
Yeah.
I'll be fine.
Yeah, Jason, so he does gymnastics.
Yeah.
I don't know if Elena told you, but so on the floor, he does this double with a half twist. And he landed it wrong and he looked up and you're not supposed to look up. And then he tore his MCL and fractured his growth plate and things like that. So, yeah. But
It's gonna be short fragile.
no, so that was what they want to make sure, because if the growth plate closes too early, because it closes when you're done growing, but that's what happens sometimes. The growth plate will heal, but sometimes when it heals, it'll close too early. So and if that happens, they have to basically re-break it, and so it doesn't close too early. But yeah, sometimes my knee does that when I land wrong in dance. So
You definitely seem like a dancer to me.
yeah, I mean, I don't want to brag, but so if you're stuck on number 2, let's write it in standard form. So now it's a little bit easier to see. And then same thing with example 4. These guys are in the wrong position, so it kind of throws off our groove a little bit. X squared plus 6x plus 5. Okay? So believe it or not, number 3 and 4, even though they look easy, these are what a lot of, if you're going too fast, you'll get these wrong. Because 2 times 3 is 6 and 2 plus 3 is 5. But also 1 times 6 is 6 and negative 1 plus 6 is 5 or whatever. So this is like one of the only trinomials that you have to go pretty slow so you don't do it wrong. And over here too, like 1, so 2 times 3 is 6, and 2 plus 3 is 5, but that's not what you're doing. You're adding to get 6 and multiplying to get 5, right? Okay. So does everyone got the first one? What do you got for the first one?
Negative 2 and 5.
Negative 2 and 5. Is that what you guys got? Because your question is what multiplies to get negative 10? So 1 times negative 10, or negative 1 times 10, 2 times negative 5, negative 2 times 5. Those are your only 4 options, right? To get a negative 10 as an answer. So this adds to get 9. This adds to get negative 9. This adds to get negative 3. This adds to get positive 3. So what do you want to end up with? A positive 3. So that's our ticket. Minus 2 plus 5. You can multiply it out. Your brain needs that. Remember, x squared plus 5x minus 2x minus 10. So that works. X squared plus 3x minus 10, check. So here's your answer. Okay? All right, do you guys need another minute to do 3 and 4, or do you got it? Anyone have an answer for 3? Yes, Audrey. Negative 6 and negative 1. So let's try that. So you get x squared minus x minus 6x plus 6. What's negative x and negative 6x? Negative 7x. So that one did not work. So this is why this one's tricky, because it looks like that should work, because darn it, 6 and 1 would combine to a 5 if that 6 was negative and the 1 was positive, but then that would give you a negative 6. So what other factors of 6 are there?
2 and 3.
2 and 3. So let's try 2 and 3. Negative 2 or positive 2?
Positive.
So if you do positive, you get x squared, 3x, 2x, which gives you a positive 5, but you got the right 6. So what's the final adjustment we need to make? Negative both, right?
Oh.
Look at this.
Okay.
So you get x squared minus 3x minus 2x, positive 6, negative 3x and negative 2x combined to a negative 5x. Okay, this is just a weird one because there's so many weird options in this small little number. This number combination is confusing. All right, can you do this one? What's that one? It messes with your head. What's the final one? What's the last one?
Couldn't you do 2 and 3?
So 2
Or- couldn't you do 2 and 3?
Well, 2 times 3 is 6, but you don't want to multiply to get 6. You want to multiply to get 5.
Oh, I flipped the 5 and
I
6
know,
around.
and that's why that makes this confusing. That's why students who do this go a little too fast and then they say 2 and 3. So that's a legitimate error that people need to hear and recognize, okay? So when you see that 5 and 6, you should go slow, all right? Depending on what order it's in, it's gonna be weird, yes.
1 and 5.
1 and 5, that's right. So, and then you're like, oh, well, there's only one thing that equals 5, 1 times 5, right? And then they're all positive, so x is plus 1 plus 5, that makes sense, okay? But see, that 2 and 3 is going through my head too. If you go too fast, you're gonna, because if these were switched around, and remember, if you have any kind of dyslexia or dysgraphia, then that's gonna be a problem for you. So go slow, all right? See, we still have that 5 and 6 here combination, but this time the 6 is the product and the -5 is the sum. So it's a little weird, okay? But do your homework, do the problems in your homework and get lots of practice, check your work. But it'll come to you. So we're gonna be doing a ton of these. So you'll get lots of practice, and it'll come to you more and more, but you'll get really fast at these and it'll be fun, okay? All right, let's move on to 70. Okay, we're going to talk about more probability. But we're going to talk about a designated order of probability. Oh, and let's just, by the way, we're going to have another test. So if you do your practice test by Thursday, then you will have extra credit. Okay, so we're going to do practice test. Let's see, what would that be? 16 now? I think 16. Practice test. Let's just make sure we have the right info here. 1 second. Yeah, we'll do 16. Practice test and test 16. So make sure you do your practice test by Thursday so you get 5 points. And then we just have problem set 70. So, all right, moving on. Designated order. Okay, so let's say that you're flipping a coin and you want to know what are the chances, what's the probability that you get a heads 3 times in a row? Okay, well, first of all, what's the probability of you just getting a heads 1 time? What's the probability? Do you remember?
50%.
What? Yeah, 50%. 1 out of 2 possible total choices, heads is one of them. So 1/2. Okay, but what if you wanted to get a heads 3 times in a row? Well, how many different possibilities do you have of flipping a coin 3 times? Anybody know? How many different possibilities are there? Well, let's list them out, unless you guys can figure it out. You're either going to get a heads, and a heads, You're going to get a heads, and a tails. You're going to get a heads, tails, and a heads. You're going to get a tails, heads, and a heads. Or maybe you're going to get a heads, tails, or a tails, heads, tails, or a tails, tails. Anything else? Am I missing anything? I think one more, tails, heads. See, these are all the different possibilities of flipping a coin 3 times. How many is that? 8. Good counting. Right, so you have 8 different scenarios. So the probability of getting a heads 3 times in a row is 1 out of 8. You see that? Now, luckily, you don't have to do this every time. You don't have to figure out all the different possibilities, because here's the deal. When you want to find the probability of things happening in a certain order, it's just multiplying the individual probabilities. Let me explain that. Okay. Okay, so let's scoot back a little bit. All right, so the study of probability is based on the study of outcomes that have an equal chance of occurring. Okay, so the heads, the chances of getting a heads is not better than the chances of getting a tails, right? Okay, so fair coin, for example, blah, blah, blah. So you have experiments and you have individual results or outcomes. So we call the set of equal probable outcomes a sample space. So this would be the sample space of flipping a coin 3 times, okay? All right. So here's the deal. When we define the probability of a particular event, it's the number of outcomes that we're looking for over the total number of outcomes. We've already talked about that. We've talked about probability, haven't we? Have we yet this year? No? Okay. So let's just back up here. So probability equals number of what we call favorable outcomes, or number of outcomes that satisfy requirements. So for example, getting a heads 3 times in a row, or just getting a heads once, over number of total outcomes in the sample space. All right, so for example, the probability of flipping and getting a heads is 1, because there's only 1 head on a coin out of 2 total sides of a coin, okay? What's the probability of rolling a 6 on a die? What's the probability of rolling a 6? Elkin?
1/6.
1 out of 6. Or for any matter, it could be any number, because there's only 1 5 on a die of 6 sides, right? Okay. So what happens is these are called independent events. Okay. So independent events do not affect each other. So independent events do not affect each other. Independent events don't affect each other. So getting a heads, when you flip a coin, the coin doesn't say, ow, I'm tired of landing on my face. Tired of landing on my butt. I'm going to land on my face. No, the coin does not get tired of landing a certain way, right? So that coin toss does not determine or have any effect on the next coin toss, right? So those are called independent events. They have no connection to each other. All right. So the probability of independent events is just number of outcomes that satisfy the requirement over total number of outcomes in the sample space. Okay. So let's try another example. Let's try example 2. 6 green marbles. And then 8 red marbles. What's the probability of drawing a okay, what's the probability of both marbles were red? Okay, well, let's just try this. What's the probability of getting a red marble? Eliana?
8 out of 14.
Yeah, 8 out of the total number of marbles, which is 14. Good. All right, now, so let's say that we got the red marble. Both marbles red. If another one is drawn, and we put it back in the urn or whatever, wherever it was. It says urn here. Whenever I think of urn, I think of Skyrim. But if we put it back in the urn, what's the probability of drawing a red one again? Same, 8 out of 14. It doesn't affect unless you put it on top and then you put flesh melting acid on the other one so you won't touch. I don't know. I'm thinking too Skyrim now. But yeah, it doesn't affect. It's an independent event, right? Now, if I would have held on to that red marble and then tried to, what's the probability of getting a red marble the next time? Well, now there's one less red marble and there's one less total marble. So probability of getting a red marble the second time would be 7 out of 13. You see how that works? Okay, because it changes. So that would not be called an independent event. Those two events together would be dependent events because the first draw affects the second one if you hold on to it. If you don't put it back in, it's going to affect your second probability. Okay? All right. Well, let's try something else here. Let's see, what is the probability? This is example 3. What is the probability of rolling a die probability of rolling a die and you have a number that's greater than 2? What's the probability of rolling a die and it being a number that's greater than 2? Anyone know? Well, how many numbers on a die are greater than 2? Elkin?
4.
4. Yeah, you got 3, 4, 5, and 6.
Would it be 4 out of 6?
4 out of 6, and you just like any fraction, you can reduce it to 2/3. Good job. All right, now here's the final one. This is a little crazy. What is the probability of rolling 2 die and getting the sum of a 7? What is the probability of rolling 2 die and getting a sum of 7? Or 2 dice, I guess, right? Because the plural of die is dice.
Wait, what do you mean sum of 7?
Well, what's an example of rolling 2 dice and getting a sum of 7? Like you have 3 on one, 4 on the other.
Oh.
Okay, so this is going to take some thinking. So what's the probability of rolling 2 dice and getting a sum of 7? So how about I give you a free problem set? And this, for those at home too, if you guys want to try this, see if you can figure this out. What is the probability of getting a sum of 7? I'll give you a free problem set if you can explain the right answer. Not just give me the right answer, but explain the right answer. So if you guys have an explanation at home too, you can chime in. You can unmute yourself and chime in. This is great. It's one of my favorite problems. Not my favorite problem. It's not factoring trinomials or anything crazy like that. Fiona, do you have something?
I don't know if it's the right something.
Okay, tell me your something.
Okay. I got 1/2 or 6/12.
Okay, good guess. But no. Thanks for trying. I think a lot of people say that too when they're first.
Yeah, 'cause that's what I got. So I'm like, okay.
Yeah. Any other ideas? Anybody at home? Okay, here's a hint. You want a hint? Think back to what we did here. You know?
1/12.
Nope.
Is it over?
It's not over 12. So you're saying that the total number of possibilities is 12. It's not. It's more than that.
Is it? Wait, would you multiply the 7 by itself?
No.
Like, could you get?
7? No.
No, like 1/49.
No. You have a pretty close. You're getting there though. Your logic is getting closer. Fiona?
6/36.
Yes. Why?
Because you multiply 6 times 6, there's 2 6-sided die, and then you add up. There are 3 possible combinations of 7 on each of them, and then you can flip the numbers.
That's right. Good. Nathan, did you have something too?
Yeah,
What'd you get?
I got what she just got because I first got 1/2, but then I realized how much it was. So
Okay. So, all right. So let me just list out all the different possibilities. Ready? You could get a 1 and a 1, right? You could get a 1 and a 2. You could get a 1 and a 3, a 1 and a 4, a 1 and a 5, or a 1 and a 6. You could get a 2 and a 1, a 2 and a 2, a 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6. You could get a 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6. You could get a 4. I can't get much higher, so I'm not gonna do that. So I'll just list them out. This is a lot of work, but it's worth it so you can see it happening. You can see the visual of all the sample space here. So see all these different possibilities, which kind of makes sense because for every number that you get on the first die, you have 6 different possibilities. So 6 times 6, okay? Now, which ones add up to 7?
Dude, it makes a line.
It does make a line, which is nice, isn't it? So you get this cool looking line there. So that adds up to 7, and that's 6 out of 36, which reduces to 1/6. Okay, isn't that cool? Now, we're going to talk about this later, but basically, well, no, actually, we'll talk about it now. So you could treat this as two independent events, okay? So really your sample space is going to be your probabilities multiplied together. So if the probability of getting a certain number on a die is 1/6, so out of 6, so if you roll 2 dice, that's 6 times 6, okay? Now back to our flipping our coin. This is an important thing for you to write down. The probability of independent events happening in a designated order is the product of those individual probabilities. Probability of independent events, remember events that don't affect each other, happening in a designated order is equal to the probability or the product of those individual probabilities. Underline product of those individual probabilities. Okay, so when we go back to our probability of getting a heads, that is just probability of heads times probability of heads times probability of heads. You just multiply those probabilities together. What's the probability of getting a heads on a coin? 1/2, right? What's 1/2 times 1/2 times 1/2? 1/8. Okay, so that makes it a lot easier. That makes it so you don't have to list out all the different probabilities. But in this case, it's a little weird because it's a sum of 7. So it's not like you're like, what's the probability of getting a 3 and then probability of getting a 4, right? So it's a little different. But the sample space is the same. Rolling 2 dice, that bottom denominator is going to be a 6 and a 6. So that sample space, total number of outcomes is going to be 36. Okay, you can do the same thing if you roll 3 dice. What's the probability of getting a sum of 7 on 3 dice? Well, you've got a lot more combinations that would equal 7, but you also have 6 times 6 times 6. So you've got, what is that, 216 different possible outcomes, okay? So I'm not going to make you do that one. All right, now this is cool, but let me do one more. We'll do a couple more because the last one is more of a public service announcement. Well, we'll talk about it later. But yeah, I think you guys got the gist of it. We're going to talk more about probability in a week or two. But for now, I think you've got enough to do your homework. Don't forget to do your test by Thursday for extra credit. You guys good? Okay. It was a good day. Good math day.
Black math! Give me some math and I'll give you some flack. Black math!